Hi there, and welcome back to another video. So in the previous video, I walked you through how to transition from plotting in the GUI to PowerShell, and then we used that information to create a script file to start parallel plotting in PowerShell. Now, this script file can be found on my GitHub, and I'll link this in the description below. But there's two main drawbacks to the script file that we ended up with. Now, the first drawback of this script is that it only creates one log file per plotting process. So if you have 3 parallel plotting processes and each one of those have 3 plots per process, well, it's only going to create 3 log files despite creating 9 different plots. And you can see that in this log file where I use this script, we're about halfway down and it's just appending this plot log to the one it was creating before. So this is a problem whenever you want to dissect these log files in order to get a better understanding of the logging process. And the second drawback is that you have a very simplistic view of the plotting process because all it spits out in the PowerShell window is the log file like you would get right here. And you don't have this nice percentage bar or the percentage of how far along you are on that particular plotting process. So in this video, I'm going to show you how you can write PowerShell scripts to both show the plotting percentage and a progress bar and create a plotting file, log file for each plot rather than for each plotting queue. Now, I broke down this process into 3 different scripts. The first script being the one that creates the plotting processes or the plotting queues and delays them for the time specified. And then the second script is the one that takes care of actually creating each plot individually so that we get individual log files rather than only one log file per queue. And then the third script is the one that gives us the progress of each plotting process. Now, I am using VS Code in this video because I feel like the code is much easier to read with the black background, but if you are following along, you can continue to use the PowerShell ISE. It's very similar. It's just a different way to write scripts. Now, let's go back to the first script that I talked about that creates the parallel plotting processes, and let's break it down line by line. Now, the first part of this script is just defining the parameters that we can use when calling this script to change how it runs. So if we change the parallel parameter when we call the script to 2, well, it will create 2 parallel plotting processes. Now, you can see that this parameter has a default value of 3. So if we don't enter in anything, by default, it will create 3 parallel processes. Now, the next parameter is the delay parameter, and this will delay the starting of the next parallel process by a number of seconds. So in this case, it's defaulted to 3,600 or 1 hour. Now, the next parameter is plot per queue. So how many plots do you want to plot per parallel process? So if you have 3 parallel processes and this to a value of 2, well, you create 6 plots in total, 2 for each process. So the rest of the parameters are basically going to be sent to the next script file in the start process command right here. And these parameters are basically going to be used to start each Chia process. Now, you may have noticed that each parameter actually has a data type listed in front of it surrounded by square braces. Now, this basically tells the script that this parameter can only accept integer values. So if we try to give it a string, well, error out. So we do start Chia parallel plotting process, we do the parallel parameter and we type out 10 rather than giving it the integer 10, well, it will fail. So this will prevent your script from failing with giving it the wrong values for the parameters. Now, you may have noticed that we assign default values to some of these parameters by doing an equal signs, but the rest of these parameters do not have default values. But these parameters do need values in order for the scripts to be run successfully. So in order to make them mandatory, we can add this parameter line up here, and inside the parentheses, we can add the word mandatory. Now, this is an attribute that we're assigning to this parameter, and you can learn more about the attributes by going to this URL, and I'll link this in the description as well. Now, effectively what this does is prevent the script from being ran unless you give this parameter a value. So if you try to run the script without giving it a value, it will prompt you for a value, and if you hit enter again, it will actually terminate the script because you gave it an empty string. So let's go ahead and add the mandatory attribute to the rest of these parameters, and we're actually going to want to add one more attribute to the directory parameters, because currently we're only specifying that we want it to be a string value, when in reality we want it to be a directory path. So what we can do is add a validate script attribute to these parameters as well. So this will run a script based on the value that you give it. Now this is going to be a very basic script, and we're going to start out by putting it in a script block using curly braces and then some square brackets to basically use a class in the .NET framework called system.io directory. And then we're going to do double colon to access a method on this class, and this method is exists. And then we're going to pass it the value of the parameter by doing the $ and underscore. So whatever we assign this variable or this parameter right here will first be ran against this script block, and if this value returns true, well then it passes the validation. If not, well the script won't run. And I'm actually missing an S right here. So now if we try to run the script again and give the temp directory parameter just a regular string value, well you can see that it does not validate the script, so the script does not run. However, if we give it an actual directory value like C users, it will pass the validation and go down to the next mandatory parameter. So now that we have all the parameters knocked out, let's go ahead and look at the script. So we have a pretty basic for loop, and what we're doing here is creating a new variable and calling it Q and assigning the value 1 to it. And we're saying as long as this variable is less than or equal to the total number of parallel processes that we want, so in this case let's say 3, we'll then run everything in this script block below. And then at the end of the script block, add 1 to the value or the variable Q. So you can essentially think of this right here as being at the very end of the loop. And then once it gets done with this, it starts back at the top. So every time we loop through this for loop, we run 2 commands. The first being start process, and this starts a PowerShell process in a new PowerShell windows and runs the next script that actually creates the Chia plotting files using these parameters right here. So we essentially pass all these parameters to the next script that we want to run. Now we also use this parameter for start process dash working directory to put the new PowerShell window in the directory of the next script file, which is in the same directory as this script file. So we're going to use the variable ps script root, which will basically put it in the same directory that this script is being ran in. Now I have an example of this down here. So we're doing start process PowerShell as the same above, and then we're doing a command get location in the working directory of C :users. So if I do F8 and run this, well you can see that it put us in the directory of C users. Now once the PowerShell window has been launched and the Chia plotting process has been started, it will start a sleep cycle for the delay that you specified. So this will basically halt the for loop, and once this is done, well it will continue it again until the Q value is equal to the parallel value. So in our case we'll have 3 separate PowerShell windows, all making 1 plot each, or whatever plots per Q you assign. So this script is pretty simple. However, if you do need a better description of how this works, I recommend watching the previous video where I go in more detail of how we created this. Now let's go to the next script that this script calls every time it goes through the for loop, and that is start Chia plotting. Now up here you can see the basic parameters that we're going to be using to create the Chia plot files themselves, and we're getting most or all of these from the previous script through the argument list. Now you can see that I'm missing like the validate script and the mandatory. I do recommend adding that to this script as well. I just didn't. I do have this line right here just to test that these directory paths are valid. However, this is not ideal because test path will actually return true if this is even a file path rather than a directory path. But if it's not a path at all, well, it will exit out of the script. Now the reason why in the previous script I used the parameter working directory and passed the path of the current script file is because I want to import the get Chia plot progress function, and that's in the same directory as all the rest of these scripts. So whenever this script is being launched, we're already in the current directory that this script is in, and this is, I think, better because you might be moving these scripts around and you kind of want to keep them all in the same place, and if you do, well, you never have to change this right here as long as they're in the same directory. Now let's go ahead and get into the meat of the script, and here we have another for loop. Instead of creating new queues, we're basically creating plot files one at a time. So we created a variable called plot number, and then as long as this number is less than or equal to the total number of plots we want to create in this queue, then we're going to run all these commands below. And then at the end, we're going to increment it by 1. Now the first two commands that we're going to run is basically creating a directory log file. So first we're going to get the current date to kind of give it a unique name, and then we're going to add that to the log directory and attach the .log file extension. The next command that we run is start process again. However, this time we're starting the Chia plotting process with the parameters that we passed from the previous script. Now there's two things to note here, and the first one is that we're using the dash pass through parameter on the start process commandlet, and basically what this does is it outputs an object of the actual Chia process, and then we're going to store that in the Chia process variable. So this will allow us to get the Chia process ID and get information about it. So the next thing to note is the dash redirect standard output. So this is basically going to be creating the log file, and we're passing the log path to this. So we'll be basically creating these log files here by redirecting the output of this process. And then we're doing no new window, so this Chia process is going to be ran in the PowerShell window and not create a new window like it normally does. Now another benefit of doing the redirect standard output is it allows the command prompt to be active again, so that we can run commands after we start this process, even though the process is running in this PowerShell window. So the next command that we run is going to be changing the window title of the PowerShell window to something that will kind of help us identify the queue and the process ID running. So here we're just basically giving it a string with the queue name, the plot number. So are we at plot 1 out of 3 or 2 out of 3? And then here we're giving it the Chia process ID, so in case we need to stop this process, it will be easily available to us. I did add a single second of sleeping just to allow the process to kind of get started and create the log file, because we're going to be directly getting the log information to get the Chia plotting progress. And there was a couple times whenever, I was grabbing the Chia plotting progress before the Chia plotting even started. So this is just kind of to mitigate that issue. Now the last thing that we're doing is creating a while loop, and basically this is creating an infinite loop until the Chia plotting process is done. So we're saying, is the Chia plotting process exited? If not, we'll continue running all the commands in this loop. So the first command that we're running is the script or the function get Chia plot progress. That is the last script that I created, and then we're giving it the log path that the Chia plotting process is redirecting the output to, and then we're using this information to create the progress bar by using the write progress commandlet. So write progress will give it a progress bar and information about the current process. So the first thing that we do is give it the activity. So which queue is this and which plot number are we on out of the total number of plots we plan on creating for this queue. Now the next thing is giving it the status of this process. So we give it the phase, the current phase that it's in, and we get this from the previous command, get Chia plot progress. And we also give it the percentage that has completed. So I should probably add a percentage right there, and then we also give the percentage to the parameter %complete. So this will update the progress bar that write progress creates. Now the last thing that we give it is the estimated total of seconds left in the plotting process, and we give it to the seconds remaining. So this will give us an estimated time that's left before the plot is created. Now the last thing that we do is just sleep for 5 seconds before we run this again until the plotting process is completely finished and has exited. Now you can change this interval to anything you want, so if you only want to get it updated every 10 seconds versus 5, that's fine too. So this while loop will continue to run until this Chia process has exited. So this accomplishes two things. For one, it gives us the progress of the current Chia process, and for two, it pauses this for loop until this Chia process has exited. Now once it has exited, well, this for loop has done one cycle, and then the plot number gets added by 1. And then a new plot file will be created as long as the plot number is less than or equal to the total number of plots we want to create. So now this solves the first drawback of the previous script, where we're creating one log file per plot file and we're giving them a unique name. Now the second drawback, remember, was the progress, and so the way we solve that is with this function right here, which is get Chia plot progress. So if we jump into this script, the first thing that you're going to notice is that I actually adapted it from the plotting manager SWAR. Now I did modify it so that we get estimated time remaining and a couple other things, but I did just see how he did it and kind of transported it to PowerShell. So essentially what this does is it counts the total number of lines in the log file and it breaks them into different parts, or the phases. So the end of phase 1 actually ends on line 801, and then for phase 2, 834, etc. Now I did have to modify it because I think his was outdated. Maybe he's already updated it, but the copy file was in a new version of Chia, so this system will break if they make any changes to the log file. Now the next thing is, since the different phases take different amount of time, well, he weighted each one per line so that the phase 1 has a higher rate than phase 4. So this will give you a more accurate of a percentage of how much it has completed. Now the first thing that we want to do is get the current runtime of the Chia process. Now we do this by getting the creation time of the log file, which is basically the same as when the process started, and then the end time is the time right now when this function is being called, and then this will give us the elapsed time. The next thing that we want to grab are the total number of lines that have been written to the log file already. Now we're going to use this and compare it to each phase lined in. So if the total number of lines that have been written is greater than or equal to the total number of lines in phase 1, well, we're going to add the total weight of phase 1 because that has been 100% completed, or 33% of the whole process. If it's less than, then we'll go into the else statement. Now the first thing that we're going to do in here is get the progress, and we do this by timesing the phase weight, so 33, by the percentage that we're done with phase 1. So our total number of lines written by the total number of lines in phase 1. So if we're 10% done with phase 1, well, we're going to do 10 times 33, or 3.3% done. And then we calculate the estimated time remaining. And we can do this by timesing the elapsed time by 100 and then dividing it by the progress. And then we take that and we minus the estimated time remaining by the current elapsed time, and then we store it into the variable seconds remaining. Once we have done that, since we haven't got past phase 1, we're going to want to exit out of this function. So we're going to do return, which will pretty much end this function and return the result back to the script that called it, and we're going to return an object, a PowerShell custom object, with the progress property, which phase it is in, which is phase 1, the elapsed time, and the estimated time remaining. Now basically we do this for each phase. So if the total number of lines that has been written is greater than the phase 2 line, then we add it and go to the next phase 3, and so on and so forth. So now that we understand what each script file does, let's go ahead and open up PowerShell and run the first one that creates the parallel queues. So it's going to be start Chia parallel plotting. We're going to assign the first parameter parallel to 2, so we're going to create 2 parallel queues. And then we're going to delay the creation of the second queue by 60 seconds. Now, of course, you want to do it more than this. This is just for demonstration purposes. And then we're going to create 3 plots per queue, so 6 plots in total. And then I just passed in the temp directory, final directory, and log directory. So if we go ahead and click enter, you can see that it opens up a new PowerShell windows, and it's going ahead and creating the first plot file. So here you can see in the title that we're in queue number 1, we're doing plot 1 out of 3, and the Chia process ID is 23288. And then here we can see the phase number, the percentage that's completed, and now that 60 seconds has elapsed, we are getting the second queue up and running. And so here we can see that this is run number 2, plot 1 out of 3, etc. So as the log file gets filled up, this will be updated. Now it does take a while for phase 1 to actually start producing lines, so it will stay at 0.41 for about 30 or 40, or I guess over a minute, and then it will start updating every 5 seconds. This will increase for the first probably like 2 or 3 minutes, and then it will stable out as more progress gets made. So now that this script has finished, because we created both of the processes, and the for loop has now completed. Now currently in both of these queue, we're in the while loop of the first run of the for loop. Now what's kind of nice about having these information in the process ID is that we can cancel this process if we need to. So process 12504, if we do stop process and we specify the ID 12504, and then we go back to the window, well, we can see that it ended that process and now it's on plot 2 out of 3. So now if we go to the log file, we can see that we have 3 log files instead of just the 2 queues like we had in the previous video. So this is extremely helpful because now we have single log files for the plotting process, and we can use these to get information about the plotting processes. Now there is one important thing that I want to note. The only way to cancel all the queued plots in this window is to exit out of this PowerShell window. Now if you hit Control-C in the window, you'll see that it makes the progress bar disappear. However, that process is still running. So process 22524, we can do git process 22524, and we can see that it's still running because we actually didn't exit the process, we just exit the while loop, getting the process progress. So if you want to cancel that process and cancel all the processes that would be created afterwards, I would just close out of the PowerShell window completely, and then now you can see that the process has actually ended, and then you can go ahead and delete the temporary files left over from that process. Now I actually have gone ahead and converted these scripts into functions and then placed these functions into the module PS Chia plotter. Now if you already have the module, you can do update module and then do PS Chia plotter, and this will add these functions to your module. Now if you don't have the module, you can do install module PS Chia plotter, and then it will install the module for you. Now if it gives you some type of error whenever running scripts, you might have to change your execution policy. So if you're unable to run any of the scripts in the module, you have to do set execution policy to remote sign, click yes, and that should take care of that. So now that we have the module either updated or installed, I'll go ahead and show you how to use the function. So you just type out start Chia parallel plotting, and then the first parameter is the number of parallel plots that you want to run. So I'm going to do 2. Then you're going to indicate the delay in seconds. So I'm going to do 3,600, and then plots per queue, I'm going to do 3. And then we're going to do the temporary directory. So mine's going to be p.plot, and then the final directory, which is h Mr. Pig, and then farm, and then my log path, which is going to be on my h.Mr. Pig, Chia logs, and tests. And then from there, we can go ahead and click enter, and you can see that it created the first queue, and then in an hour it will create the next one, and it will create 3 plots per queue. Now if you run the command and this window just quickly opens and closes, I recommend that you use the no exit switch parameter on this. So start Chia parallel plotting and then do no exit, This will prevent the window from automatically closing so that you can see the error and try to fix what needs to be corrected. Now, if you do want access to the scripts that we talked about in this video, they are on my GitHub, so you can check these out, modify them how you want, or you can just use the functions that I created and put into the Chia plotter module. Now, just to give you a little sneak peek about something else I've been working on, I have been working on a kind of like a Chia plotter manager for PowerShell, and this will be launched by PowerShell directly. So show Chia plotter will launch a GUI, and then from here you can manage your Chia plot. So essentially what you would do is click new job, and then from here you can dictate the total number of plots you want to create for this job. So if I want to create 5, the parallel count, so how many parallel processes you want. So let's say I want 3. The delay between the creation of these queues, so let's just do 10. And then the first delay is just kind of like you know, before the job starts essentially. So let's just do 5. And then I went ahead and added the directory files. Now this still does need a lot of work obviously, but I just wanted to give you a little sneak peek. So if you do start job, it has some validation. So the drive letter is wrong on these two. So if we do start job, well, you can see that it started the job up here. It's currently waiting those 5 seconds, and then it's right now it just starts the notepad process because I'm still testing it out and I don't want to test out starting Chia processes. So if we close this, and now another one started after 10 seconds, and then this one should start. So then we'll have 3 parallel processes, and then once these are completed, it will go ahead and launch them until we reach our total number of plots that we want to create. Now it has progress, the estimated time remaining, of course. You can open up the log file. Obviously there's no log file currently, or I guess I have it pointed to one as a demonstration. And then you can also kill the process directly from this as well. So if we do kill process, it will close it, and then a new process will be started. And then all the completed processes are listed down here. If it's a failed because we killed that process, well, obviously it will show up as red and failed. And then here you can see that the plots completed is 1. It just means that the process was finished. So if we close out of these normally, you know, as if the Chia process actually finished like normal, it will show up down here as completed and be green. And then here you can see that, you know, once this queue is done, it will be listed as finished and this one as running. So once we close out that one, the last one will be finished, and then the job will also be finished. So I just wanted to give you a quick overview of what to be expected from this plot manager. I do hope to get it finished soon, but it might take some more time. Now I hope this video was helpful in improving your scripts or improving your plotting in PowerShell. And if you have any questions, please leave them in the comments below. And of course you can find all the links in the description. Alright, bye.